Welcome back to your favorite class of all time. This is your humble instructor, Chad Bemis. Today we're going to look at Module 1.5, Measures of Central Tendency. So as you can imagine, central tendency means when you're looking at data, you're looking at things that are measured around the center, things like the mean or average, the median, which is the middle value. So physically, if the data looks like this, we look for the value that's literally in the middle of the set, and the mode is the one that occurs the most frequent. Switch to black here. All right. So when we're talking about the mean value, this is hard to see because of the colors, but let me try a different color here. The mean value here is the average of a given data set, and it's calculated by finding the sum of the data and dividing the sum by the number of values. So if the sum of the data is 200 and the number of values is 20, then the mean would be 10 or 10.0 depending on what it is that we're measuring. So you literally, the summation notation, the sigma, means that you add them all together. It works well for quantitative data. Quantitative data, of course, meaning numbers. It enables us to find sort of a representative value. And it includes all the data in the calculation. So these are some of the things that we have to keep in mind. However, if we have extreme values, extremely low or extremely high values in the data set, the mean is heavily influenced by those. So insulin shots per day, average number of insulin shots, that could be the average number that a PA has administered or a nurse, or it also could be the average number of shots that a patient receives in a day. Or another example, the mean height of 6-year-olds, the average height of 6-year-old boys or 6-year-old girls. Sometimes we differentiate those. And then, for example, the mean age of Alzheimer's patients, or another way to say that would be the mean age of onset of Alzheimer's. Okay, the median. So as I mentioned earlier, the median is a middle value. Although that definition is a little bit misleading, because if there's an even number of data points, then it's actually the average of the two middle values. So to make it simple, if I have the values 1, 4, 7, 9, and 11, how many values are there here? That's right, there's 5. So I'm literally looking for the middle value. So pretty obviously that's the mean in this case. So that's great. If we have 5 values, no problem. But what if there's 501 or 10,911 or something like that? How would we determine the minimum value? Well, notice that the third one, which is 7, is the median, right? The third one. And we can calculate the 3 by taking the number of values, n, adding 1, and divide by 2. And then put a th or an rd or an nd after it. So what if there were, I didn't even list them, but what if there were 19 values? Then the median would be which value? Well, it would be the number of values plus 1 divided by 2 with a th on it. So 20 divided by 2 is what? 10 with a th. So whatever the 10th value, if it's listed from low to high or high to low, either way is fine. It's going to be the 10th value. So again, we list the data in order. If it's not in order, then the median that you calculate will be wrong if you're using this formula. for an odd number of values, which is what we did here with 5 and here with 19, you literally just take the middle value of that list. But the question comes up, well, what if there's an even number of values? Well, then it's the average of the two middles. The average of the two middle values. It's also used with quantitative. And the median is not as influenced by the extreme values and outliers as the mean is. And so you can think about what are some examples that we use the median instead of the mean. One is housing prices. You may have heard the median housing price for a particular neighborhood or city might be $300,000. And that takes into account all of the housing prices, but any houses that are, let's say, mansions in that neighborhood, $10 million homes, or shacks, shanty towns worth, let's say, 10,000, these sort of are not included in the sense that the median is not affected by those numbers, right? Only in the sense that they are part of the list is it affected. So it really gets to the heart of what the housing prices are in that neighborhood. So this is, again, this is sort of like I was doing over here, n plus 1 over 2 value in a list when n is odd. And it's the average of the two middle values when it's even. Okay, the mode. The mode is the most frequently occurring value in a data set. And it's best used with qualitative data. And by that I mean if you have qualitative data, let's say eye color, green, blue, brown, right? And we're trying to find, you know, of that list of data or this list of people, what is the most common eye color? My guess that it would be brown, but I could be wrong. So you could have a list of 500 people and you could ask them their eye color or figure out what their eye color is, and then the mean would be the one that occurs the most often. If you only have one repeating value that exists in a set, then we say it's unimodal and it's the only mode. So if I have 0, 1, 3, 3, 3, 4, 9, 11, and 12, then what would the mode be? That's right, the mode would be 3 because it's the only value that occurs more than once. So it's unimodal and the mode is 3. Oops, sorry, I shouldn't have written in front of that. Get a little eraser there. Anyway, so here the mode is 3. Let me do this. That gives me a little bit more room here. Okay. If two values occur equally as often, we say it's bimodal. Okay. So if we have 0, 0, 0, 1, 1, 1, 2, 2, 5, 5, 7, and 9, then what is or are the modes here? Well, 0 occurs 3 times, 1 occurs 3 times, and the others occur less than that. So that'd be bimodal, and the modes are 0 and 1. If more than two values occur equally as often, we say it's multimodal. So if I had 0, 0, 0, 1, 1, 1, 2, 2, 2, 5, 6, 11, and 12, then 0, 1, and 2 are the modes. If no values are repeated, we say there's no mode. So 0, 19, 40, 47, and 100. That's the data set. Nothing occurs more than once, so we say that there's no mode here. Hopefully that makes sense. Okay, so we can use an example to find the mean and the median using the calculator. So to find the mean, what would we have to do here? To find the mean, we would have to add up all of those values and then divide by what number? That's right, we would have to count how many there are. There's 5 times 4 is 20 values, so we would have to divide by 20, which is the number of values. Okay, so go ahead and do that. You can pause the video and then come back. So another way that you can do this in the calculator is there's a stat button. Click the edit button and then create a list of numbers in list 1 or any list, but list 1 is the default. So once again, stat and then the edit menu. In many of the calculators it'll say L1 and then it'll have a line, right? L2, L3, and you would enter the data in this list right here. So go ahead and do that right now. Pause the video and come back. Once you've got the data entered, by the way, every time you enter a value, you click enter, and then you enter another value, click enter. Once you've done that, hit the stat button once again, then go over to the calculate menu, select number 1, which is one variable statistics, and then enter. Now notice that didn't specify what list. If you want to specify list L2, you would go second 2. You'll notice that above the 2 key on the TI-8483, it says L2, right? So then you would hit enter after that. If it gives you an error, that means that you need to go back and fill out the values of the list in the appropriate one. The X bar value that's given, that's the mean value. And then the median says MED. Okay. So the mean should have come out to 87.5. And the median should have come out to 88.5. Remember, this was the sum of all the values divided by the number of values, which was 20. The median, remember, is either the middle value or the sum, or excuse me, the average of the two middle values. So what this tells me is that the two middle values were probably 88 and 89. So remember, the middle value here is going to be 20 divided by 2, which is 10th, plus 11th divided by 2. So this must have been the 10th value in the list. This is the 11th, and then the divided by 2 would be 88.5. So that's why the median is not one of the values on that list. So in this case, the modes are 85, 88, 89, 90, and 92. So it is a multimodal. Okay, so let's see if we can find the mean and median from a frequency distribution table, which we've studied before. So let me go back to the other program so we have a little bit more room to do this. Okay, so hopefully this is large enough that you can see this. If it's not, then I can do this. So here we have the data 70 to 74, 75 to 79. So first of all, what is the class width for each of these classes? Remember that the class width is determined by the lower class limit of one class minus the lower class limit of another. and then the class midpoints are 72, 77, 82, 87, and so on. Okay. So if we don't know what the data are, what we do is we use the midpoints. Does it make sense that we use the midpoints here if we don't know the data? So again, the frequency, we have one item in that list. We have one item in that list, and so on. So it should make sense that we have to use representative values, and the representative values are the midpoints. So what we do is we take into account the frequency for each class and multiply it by the midpoint. So what we do is we take the 72, which is the midpoint of the first class, times its frequency, and then we add the 77 times its frequency, and then we add all the way down. So that's what was done here. So 72 plus 77 plus 164 plus 522 all the way down, and they got a total of 6993. You can double check that that's correct. Then the question is, what do I do with that 6993? So the sum of all the values, the sum of all the x's, is 6993. What's n? What is the number of values in the list? It's the total of the frequencies, which is 69. So let's double check that on our calculator to make sure that's correct. And it looks like it came out to about 101.35 approximately. Since the data was given as whole numbers, we can round that to 101.3, because this was originally 3478, right? So we use that number to determine where to round, so it'd be 101.3. All right, so that's the mean. That's the x bar, that's the mean. And then the mode is the most occurring value, so you just look at the largest number. So that would have to be 107 is the mode. Does that make sense? So if you had multiple frequencies of 17 and that was the largest amount, then you would have a multimodal list. The median is a little bit tricky, but it's doable. So if you know that there's 69 values, you work way backwards. So we would go 69, add 1 divided by 2, that would be 35 with a th, 35th value in the list. So you can think about how you would find the 35th value of the list. 1, 2, 4, 10, 14, 25, 37. Okay, so I went too far. So if 102 occurs at the 37th, 36th, and 35th value. So the 35th value in the list, we use the frequencies to figure that out. So 102 is the median. Does that help? Remember, it's an odd number of values. Now, even if it was an even number of values, we would have 102 anyway, because remember, there's a whole bunch of, there's 12 102s. There's 102, 102, 102, 12 times. So we would average those and get 102 anyway. I hope that makes sense. That concludes the film for this time, the video. And please WAMAP message me or email me if you have questions. Thank you so much.